Hi there, my name is Mitch Harlabedis, and in this video we will see together through a worked example how we can solve a system of two linear equations with two unknowns by applying the method of elimination. We will describe in details the full method in simple steps. And let's begin with the first step. In step one, it's the setting step in which we make sure that both equations are presented in standard form. And when we say standard form, I mean in form ax plus by equals c. If they are indeed given in standard form or right after our operations needed to be done so that we bring them in these forms, we name them, then name them. In this example, where we are asked to solve by elimination the system that contains the equations 2x plus 3y equals 13 and 3x plus 5y equals 26, we can see that indeed both of them are in standard form, so that is already done. So I should begin by just naming them. This could be 1 and this could be 2. Then let's see the next step. In step 2, I decide it's totally up to me the variable I want to eliminate. Okay, so let me decide that I will eliminate, let's say, variable x. Then, in step number 3, based on the variable that I decided to eliminate, I will multiply its equation with the coefficient of the variable I chose to eliminate of the other equation. Let me make totally clear what I mean by that. I just decided that I wish x to be eliminated. Then I will consider the coefficients of x in these two. On top, it's 2, and on the second one, it is, let me make that here. On the second one, it's 3, okay? I cannot do it like that, so I'm gonna paint it. Here, it's 2, and down, it's 3. So, based on this methodology, I will multiply the first equation by 3, and I will multiply the second equation by 2. This means when we refer to multiplication, this means that I should multiply by that number each and every single term of each equation. So, given 2x plus 3y equals 13, which was equation number 1, if I want to multiply this by 3, this will become 2x times 3, 6x, 3y times 3 plus 9y, 13 times 3 equals 39. Similarly, in the second equation, which was 3x plus 5y equals 26, I decided to have it multiplied by 2. Once again, this means that I should multiply each and every single term of that by 2. So 3x by 2 should be 6x. 5y times 2 should be 10y. 26 times 2 should be 52. Now, here we have an indicator of things going well. At this point, coefficients of variable I chose to eliminate, in this case, coefficients of x, should be equal, should be the same. Always, if you follow these steps, at this step, the coefficients of the variable we wished to be eliminated will be the same. Now, I want to share something with you. When I was in your age, I learned that in Greece as not elimination method, but we rather called it method of opposite coefficients, because that was what we were trying to do. We were trying to make either the coefficients of x or the coefficients of y to become opposites. And then through addition, we would eliminate them. Now, by keeping that in mind, I will move on step number 4, in which I will say that I am going to multiply the second one by -1. Although this is not totally restricted, I should multiply any of them by -1, but it would be better if we just multiplied the second one. So I'm going to keep the first one as it was, 6x plus 9y equals 39. And the second one should be multiplied by -1. Let's write that here. So 6x times -1 should be -6x. 10y times -1 should be minus 10y. And 52 multiplied by -1 should be -52. Then, in step 5, I add them vertically, which means that I should do this. By adding them, now you should be able to see why we just called it elimination method. 6x plus minus x, these two are cancelled out or else eliminated. 9y minus 10y should be minus y, and 39 minus 52 should be -13. So negative y is -13, which similarly means that y should be 13. And this is the value of one of the unknowns. Remember, however, that when we refer to a solution to a system, we mean a pair of values. We don't just need the value of y, we want the corresponding value of x as well. So the remaining step should be the following. Step 6, use this value in any of the above equations and solve for the second variable. So this means that I should consider y equals 13, and I should substitute this value either in the first one, or in the second one, or in any of the following equivalent equations form. I'm going to do that here on the first one. So for y equals 13, the first equation, which was 2x plus 3y equals 13, should become 2 times x plus 3 times 13 equals 13. So 2x plus 39 equals 13, which means 2x equals 13 minus 39. So 2x is negative 16, which means finally that x should be minus 13. Don't forget, however, that a solution should always be given as a pair of values. So in step 7, which is more like a typical step, we can say that give your answer as a pair of values. So my solution to that system would be x comma y is minus 13 comma 13. So really quick. In step 1, we make sure that both equations are given in standard form. Once they are done in this form, once they are written in this form, we name them 1 and 2. Then it's up to us to decide the variable we want to eliminate. Based on our decision, we should take the coefficients of this variable and, in a way, cross-multiply them, meaning that I should take the coefficient of the first equation and multiply that coefficient on every single term of the second equation, and I should do the same for the second equation, meaning that I should take the coefficient in second equation, and with that, multiply the first equation. Once I do that, then I will see that the new two equivalent equations that should be formed will have something similar. The parts that contain the variable I wanted to eliminate should be the same. And this should work for us as a great indicator that things are really working well. Remember, I learned it as a method of opposite coefficients. So I need to make them opposites. How can I do that? I should multiply one of them, the second one, I should multiply by -1. By doing so, now I managed, in fact, to have them opposites, and then I should simply add them vertically. This vertical addition will eliminate, this is why probably they call it elimination method, this will eliminate the variable I wanted. I would be left with one equation of one unknown. I should solve it, and then by taking that value again, I will return in any of them and find the variable, the second variable as well. Let's see a second example. Solve by elimination this system. 2x plus 5y minus 4 is 3, and y equals 3x minus 2. Although it would seem easier for this one to be solved by substitution, here we are explicitly asked to do so under the elimination method. So to begin initiating this method, I know that I should express them both in standard form. Let me do some preparation. 2x plus 5y is 3 plus 4. So this means that the first one should become 2x plus 5y equals 7. And then the second one, minus 3x plus y is -2. So I'm going to name them by 1 and 2. And then I'm going to decide to, let's say, eliminate this time. Eliminate. Let's eliminate x. Since I want to eliminate x, I should consider the coefficients of x. This one is 2, and that one is -3. This means that I should now multiply the first one by -3 and the second one by 2. Multiplication means horizontal one. I should take 2x multiplied by -3, so -6x, 5y multiplied by -3, so -15y, 7 multiplied by -3, -21. In the second one, minus 3x plus y equals -2 should all be multiplied by 2. So again, -6x plus 2y equals -4. Now x's are the same. Great. Things are really working well. but I want them to be opposites. For that, I should multiply just the second one by -1. So I'm going to keep the first one exactly as it is. And on the second one, I should have everything multiplied by -1. Practically, this means that every single term of that will change its sign. So from 2y, it should become -2y. From -4, it should become +4. And now I should add them vertically. -6x plus 6x are cancelled out. It's -17y. -21 plus 4, it's -17, which means that y is -17 over -17. Y equals 1. Now that I have the value of y, I will substitute that anywhere. So let's do that on the first one. 2x plus 5y equals 7. This means that 2 times x plus 5 times 1 equals 7. So 2x plus 5 equals 7. 2x is 2. So finally, x is also equal to 1, which overall means that the solution xy is expressed as 1, 1. And that would be all. I hope this video really helps you understand better the way we act in these exercises. However, if you still face any issues, if you still need further clarification, please leave it as a comment below the video, and I will try to respond back as soon as possible. Thank you for watching, and we'll see ourselves in one of the following videos. Have a great day.